Okay, let's continue this exciting story of local and regional trends in space and time. I have to be in display mode before I can bring up the laser pointer. Okay, so continuing, India is getting a higher proportion of its JJS rainfall from short-lived wet extremes. So this has been said in many ways. We're looking at percentage of JJS rainfall. How is the rainfall coming? There is a question of is it decreasing or increasing, and then there's a question of number of rainy days. If you even if you reduce the amount of rainfall, if you squeeze the reduced rainfall into fewer days, then they have to be raining heavier, right? So this is saying India is getting a higher proportion of its JJS rainfall from short-lived wet extremes, so short duration heavy rainfall events. Percentage of total JJS rainfall from heavy rainfall events has gone up. There is of course intra-annual variability still from El Niños, La Niñas and other modes of variability, and there is a linear percentage of total JJS rainfall from heavy rainfall events that has positive trend. If you look at the increase in the number of dry days, then it turns out that they are offset by, but there is kind of a decrease in moderate rainfall days in 9% of the tehsils during JJS days. What do we mean? I didn't read it properly. Increase in the number of dry days is offset by the decrease in moderate rainfall days in 9% of the tehsils during JJS rainfall. I'm not sure if the sentence makes complete sense. Dry days are offset by decrease in moderate rainfall days. Okay. Changes in the frequency of dry days in the last decade. So here there are negative, which means number of dry days have decreased, but there is an increase over this band here of number of dry days, and you can see that there is a 40-year trend in the significant changes in the frequency of dry days, which have decreased here. So that's number of days per year that is negative. So there is obviously consistent with increased rainfall that we looked at, and moderate rainfall is supposed to have increased in some places, but it's not so obvious here. But this is a decadal change, which again, this region is always showing up with various ways of long-term trend, decadal change, and monthly changes as well. And this is the changes in frequency of moderate rainfall in last decade and the 40-year trend. So you can see that there is a decrease in the moderate rainfall days, and there is a number of dry days is also increased. Okay, whereas here moderate rainfall days have also increased, and they are also associated with decreased dry days. Okay, so the 40-year trend holds up here. This is only a decadal change. The 40-year trend disappears here. We are just adding more and more details, but they're still interesting. Northeast monsoon over India shows a slightly increasing trend at the rate of 0.7 millimeter per year. So you can see good intra-annual variability, but a linear trend that is statistically not significant. So remember, this is increasing, but it's not statistically significant. That you have to remember. 48% of the tehsils in India saw an increase in October rainfall in the past decade. This is consistent with what I said about the southwest monsoon withdrawal changing and basically providing a lot more late season extremes, especially in these places where you have decreasing rainfall in the previous JJS rainfall, right? So you have a lot of negative trends here in rainfall for all months, but you can see that October rainfall shows positive trends, but there are some regions which also have October rainfall deficits. There is October rainfall increase, so OND is shown increase here, and then the question is whether this is related to southwest monsoon lingering on into October, or is it northeast monsoon. Okay, so statistically significant also at the 40-year trend, and this is trending up in terms of the October rainfall increase, and this shows that coastal rain also has shown October increase, which means obviously it may not be northeast monsoon. On the eastern side of the Ghats, you expect maybe northeast monsoon has an impact, but when you see also on the west coast, then you know that the story has to be more complicated. This is changes in November rainfall, massive deficit across the band here, but increase here, but you have to be careful whether this is related to monsoon circulation or mostly influenced from western disturbances and other things. There is a decreasing trend in the western disturbances, but does that mean rainfall precipitation is also decreasing, or is it just the number of western disturbances decreasing? I won't get into the detail, but you can see massive deficit here in terms of the change in the last decade, but 40-year trend shows that this region lights up in terms of positive trend over the 40 years for November rainfall, but not much else is significant over here. But if you look at December rainfall, this picture looks quite different. Lots of increase here in the last decade and lots of increase here, lots of deficits here. So November also decreased here, increased here, but you can see December decreased pretty much across the board. And there is a 40-year trend here for December rainfall that doesn't show up in this figure here. So that must be the Leh Ladakh Himachal region, but make sure what region it is. And there is a positive trend in the December rainfall. And if you look at tehsil wise coefficient of variation, typically when you have low mean, there is high standard deviation and high coefficient of variation. So these are dry desert regions. Of course now you have increasing rainfall, but this is also increasing the coefficient of variation for the southwest. And for the October, November, December, you get some increases, and well, these are all positive. So this is less than 50, and this is getting up to more than 125% increase in the coefficient of variation. Here the coefficient of variation is greater than 35%, so JJS is not as large as the increase in coefficient of variation here. Of course you have to look at the mean as well. So it just means that mean may be low, but the variability may be very high, whereas there are other regions where the coefficient of variation has changed, but not by much. Okay, there is another way to look at it. Majority of India's tehsils in the north and east zones show high variabilities in monthly rainfall. So this is a nice figure because it looks at distribution of percentage of tehsils that are affected in each month of the year. So going from June to December, so you start with the rainy season, summer, and go through OND, and these are percentage of tehsils that have seen a decrease in rainfall and tehsils that have seen an increase. So you can see that there depends very much on the month. So there's a huge spike in November here in terms of decreasing rainfall, but December jumps back up, and seems like there are no tehsils which are seeing a decrease in variability. Okay, that's the how to read it, but you can see that when you look at specific regions, north, northeast, and then we will look at west, central, south, and east. So you can see Himachal Pradesh has seen lots of decreases in most months, but has seen a jump or no decrease, but tehsils, number of tehsils seeing increased rainfall in November is high and drops in December again. So very in time it's a very local distribution. So there is a jump in June, July, and then jump in November, but there is a decrease in the number of tehsils that are seeing a decrease in rainfall. Uttarakhand again mostly a decrease in terms of tehsils that are affected. Punjab has again a jump in I think August and then November. These are consistent with the trends we saw before. Chandigarh has a very strange distribution, decrease in all months except in maybe November, and so on. Okay, so obviously it's statistics, causality or the mechanisms have to be understood. The West has seen increased rainfall and increased heavy and very heavy rainfall. So you see that the decrease is mostly in the OND season, and Central has also similar story for Madhya Pradesh, but Chhattisgarh has seen very erratic rainfall, and it gets more of the late season extremes that sometimes wipe out the seasonal deficit, and you don't know whether to define the season as deficit or normal, right? So in the south, the story is much more uniform. There is mostly increased number of tehsils seeing more rainfall, but in the east, it's a bit more complicated. So Odisha, Bihar, Jharkhand, West Bengal, there Chhattisgarh is part of this actually, even though it's counted here as central. So they are ending up with June, July, August deficit, but then they're getting late rainfall excess to make it up. Okay, so I think I'll come back and read the conclusions in the next podcast because I have to run to my class now. I have a class to teach and I want to be ready. So let's leave this here. It is only 11 minutes long, but that's okay. I'll take my time reading the conclusions in detail and have some discussion on the potential mechanisms and local and remote forcings. The way I think about it, global warming is having an impact on the Indian monsoon onset, withdrawal, distribution, and everything, and the wind shifts that we talked about, etc. And then there are local amplifiers. So the coastal warming on the west coast and Bay of Bengal warming and synoptic activities and so on are, kind of amplifying global impacts by local warming. Local warming itself is a response to global warming, of course, whether it's shifted winds or some other heat input mechanism from the, let's say, Pacific or Southern Ocean, and so on and so forth. So we'll come back and make some more points in the next podcast.